All right, welcome to Mr. Hassler's first screencast. This one is on integers and absolute value. We're going to start out by looking at integers. That's that word right there, and it's all positive or negative whole numbers and the number zeros. So what we have here is a list of numbers, and we have to decide, are these positive or negative whole numbers, which would make them integers right there, or are they not integers? Are they not positive or negative whole numbers? So I'm just going to grab this. I look at this, I see 1/2. 1/2 is not a whole number, boom, not an integer. I'm going to take negative 39. It's a negative number, it's an odd number, it's divisible by 3, whatever. It's a whole number. That does make it an integer. It is a negative whole number. As with 375, also a whole number, this time a positive, a large whole number nonetheless, therefore an integer. 5, whole number, integer. Negative 7, whole number, integer. Now, what I have here is negative 0.5, which is the same thing as negative 1/2, not an integer. I have this, which is the pound symbol. If you're in England, you're using money, it's called pounds. That's not even a number, so of course it's not an integer. And then this one is the one that a lot of students today struggled with because it had a decimal. We see that there is a decimal right there, but all we've done is we've added a decimal and annexed to 0. Technically, we could do that with any of these numbers. It doesn't change the value, which means that this is, in fact, an integer as well. All right, on our next slide, what we're looking at here is just different integers in kind of word problem form. Blake Griffin, great player for the Los Angeles Clippers. His vertical jump is 35 inches. Actually, it's 35.5, but I cut it down to 35 to say that it is an integer. How would we write that as an integer? We would just simply write 35. Now, technically, we could say positive 35, but we don't need to. We live in a positive world where we can show things that are real, so 35 is implied positive. If you guys have seen The Dark Knight, Batman, Christian Bale is the actor. Well, there is a movie called The Machinist where he lost 63 pounds to play that movie role. He got wicked skinny. It was gross looking, scary, whatever. He got really, really skinny. How do we represent losing 63 pounds? It's not plus, it's minus a negative 63. That's him losing 63 pounds. So plus 35, minus 63, two very different integers expressing those. Now, I lost $1, I found 4 quarters. That means I had a net change of 0. That means the integer that I'd be using here is our 0. Now, when I asked this one today, I said, what is an integer that is 5 away from 0? And right away, a ton of people got 5. They said 5 is 5 away from 0. 1, 2, 3, 4, 5. Absolutely. And quite a few people also got negative 5, which is also 5 away from 0. They're the same distance away from 0, and that's going to play an important role as we move on to the latter part of this lesson. They're both 5 away from 0. The next kind of idea I wanted to say is, where does 0 go on the number line? Now, a lot of kids looked and said, well, just right there in the middle. Well, technically, 0 can go anywhere, and in fact, it doesn't even need to be on this number line. If I put that 0 right there, then that means that this is negative 1, and this is positive 1. Now, again, we wouldn't need that plus 1, but if I moved that 0 over here, everything with it would move. We understand that negative 1 is always on the left of 0, positive 1 is always on the right of 0. So the idea here being that it doesn't matter where 0 is, the relationship between the other numbers are going to be the same. You see, as you get, as you move to the left, the numbers get smaller. So as we see, like here's the biggest number on this number line, 3, and we're getting smaller, 2, 1, 0. Negative 1, negative 2, negative 3. Again, the other way, negative 3, negative 2, negative 1. Negative 1 is bigger than negative 3. Sometimes that takes a little bit of getting used to, a little bit more time to understand, but the basic premise is that is bigger than that, even though 1 is smaller than 3. Negative 1 is larger than negative 3. And would you rather owe $1 or owe $3? You'd rather owe $1 because that's less that you'd have to pay back. Kind of the idea being it's closer to 0, that means its value is larger. I skipped over, is 0 the smallest number? Of course, we cannot say that 0 is the smallest number. There is no such thing as the smallest number. When we take an infinite set, negative infinity, we can't actually identify what that smallest number is, but no, 0 would be right there smack dab in the middle of the number line. But this is a number line activity, very much like your homework tonight, page 2 in the gray workbook. I take these three numbers here and I say, hey, when I'm looking at something like this, I look and say, what is my largest number or my smallest number? In this case, this is my largest number and this is my smallest number. And I just make an executive decision. Which one do I want to use? I'm going to say, in this case, I'm going to start with my smallest number. My smallest number is this -3 right here. I'm going to put this all the way on the left. Then all I'm going to do is I'm just going to count up to place these. I know that both of these 2 and 5 numbers fall somewhere to the right of that -3, so I'm going to say -3, -2, -1, 0, 1, 2. And that's where my 2 falls. And I can take this 5, start right here, and say 2, 3, 4, 5. Now I also could have moved these numbers over and said, hey, 5 is there, 2 is there, and 3 is there. It doesn't matter. I just recognized that moving the first one over, the largest one over 2, meant I had to move everything else over 2 to maintain the integrity. Now, how do you think these next two are going to go? Again, pick the smallest or the largest. I see here's 207, which is my largest. Going to take 202 and take 207. 6, 5, 4, 3, 202. Take 199, 202, 201, 200, 199. And again, same relationship. If I just moved it over 1, 2, 1, 2, 1, 2, 199, 200, 201, 202, 203, 204, 205, 206, 207, 208, 209. This is the only one that kids really struggled with at all today because I said, what is the smallest number? And everyone said -14. In fact, that is the largest number. So I'm going to start there. -14, -15, -16, -17, -18. Okay? -20, -19, -20, -21, -22, -23. And again, if I was to change that, again, maintain the integrity of the number line, 1 over, 1 over, 1 over, that's all. Either way is correct. Both ways will suffice. Now, what the concept is, absolute value, that we're going to talk about next. Absolute value has 3 key factors. It's just the distance of a number from 0. The distance of a number from 0. 5 is 5 away from 0. -5 is 5 away from 0. It's always positive. You think about it, if I ran 2 miles out and 2 miles backwards, I didn't unrun those miles. I ran a total of 4 miles out and back. Distance can't be negative. So when I'm looking at absolute value, I got to recognize that doesn't matter if it's a negative or a positive inside those absolute value signs right here that we're about to get to. It just matters that it's a positive number. Absolute value is always a positive number. And I'll give you an exception where it's not a positive number exactly, but that's because of something else that I'm going to do. Now, it's represented by this. These are called absolute value signs. We don't really call them brackets or parentheses. They have their own special rules, and it says what this is saying is the absolute value of x. And x is a variable. It could be anything. In this particular case, it's nothing or everything, depending on how you want to look at it. So the question here is the absolute value of -3 the same as the absolute value of +3? Well, is that saying is 3 and -3, are they the same distance away from 0? Let's count. 1, 2, 3. Well, 1, 2, 3. So in fact, what we have here is that the absolute value of -3 is exactly equal to the absolute value of +3. We don't need that plus. That's because -3 has an absolute value. Excuse me, let me erase that. -3 has an absolute value of 3, and +3 has an absolute value of 3 because they're both 3 units away from 0. And this is a blank slide. Hi, have a great year. And I'd like to imagine that my handwriting will improve, but let's be honest. All right, evaluate. That means solve. That means try and figure out what it's worth. Let's start by looking at each of these different things. -5, absolute value of -5 is how we just say that in words. What is the absolute value of -5? Well, it's 5 away from 0, so the absolute value of -5 is 5. Doesn't matter that it's left, that it's negative. It's just a +5 absolute value. The biggest mistake people made all day today in class, when they saw this, they'd say, the absolute value of 27 is -27. What's the mistake that they're making? The greatest answer I got from anybody was they're saying, well, if it's negative, it's positive. If it's positive, it's negative. And that's not right, because as we remember, absolute value is always and only positive. So let's get that, let's erase that and say, no, that's incorrect, and say 27 is the correct answer. Now this one's a little bit tricky. What's the trick here? I didn't have the absolute value signs. What's the only thing that's equal to -3? -3. Easy as that. And finally, our last little tricky one, negative absolute value of -5. Negative absolute value of -5. Not like parentheses where a negative times a negative is a positive, or this is an opposite. All we're just saying is, what is the opposite of the absolute value of -5? I know the absolute value of -5 is 5, and the opposite of 5 is -5. So just that negative is still applying because it's on the outside of the absolute value sign. Now these are three different ones. 15 minus 9, or more correctly, the absolute value of 15 minus 9. We're also looking at the absolute value of 15 minus the absolute value of 9. And we're looking at the absolute value of 15 minus the absolute value of -9. Guess what? Each of these has an answer of 6. 15 minus 9 is 6, or more specifically, the absolute value of 6. The absolute value of 6 is 6. 15's absolute value is 15 minus the absolute value of 9. This is just 15 minus 9, which is 6. And 15's absolute value is 15 minus the absolute value of -9 is also 15 minus 9, which is, also 6. Simple as that. Same answer, 3. Our exit slip today was from The Biggest Loser. Jeff lost 100, Joan lost 60, and Jimbo gained 40. Jimbo wasn't very serious. He was just there eating off the buffet. So Jeff lost 100 pounds. Joan lost 60, Jimbo gained 40. So what are these numbers as integers? We're very back to the beginning of the lesson. We have -100. That's our integer because it's lost, so it's negative. Joan lost 60 pounds, so that's -60. And Jimbo gained 40, so that's just 40. I could put the plus. I used green to indicate positive. But the idea is, since there's no negative there, that's a positive. So the numbers are -100, -60, and 40. How much total weight was lost? Well, let's look at this. If so-and-so, if Jeff lost 100 and Joan lost 60, together they lost 160. But Jimbo gained 40, so 160 minus 40, because again, this is negative, this is positive. Our answer here is going to be 120 net pounds lost. So they lost 160, but Jimbo gained 40 of those back. And then this last one is essentially what is the total change in weight amongst all contestants. That's just the absolute value added together. Absolute value of 100 is 100. Absolute value of 60 is 60. Absolute value of 40 is 40. 100 plus 60 is 160. Plus 40 is 200. There's our answer, 200. Thank you for tuning in. And if you have any questions, just be sure to put a comment down in the comments section or just ask me tomorrow in class. Have a great day.